the rest, we found the coefficient to be 95 over 53. Okay, that we know. And then from here, same thing now. Okay, so we want to know what is our n width multiplied by depth. Okay, so if we look at this diagram over here, so let's consider 1. Okay, so 1 is the top plate on top. The coefficient is 1. The width is 12. Okay, so the top plate is this plate where I'm talking about now. Okay, the depth is equal to 0.5. So this is equal to 6. And then number 2, so this is our number 2 and number 3, and this is the way we divide it. Okay, so now we have 95 over 53. The width is 0.5. The depth is equal to 6. Okay, so 95 over 53 plus 1.5 times by 6 is equal to 285 over 53. And we know number 2 and number 3 are the same. Okay, and then the last one is the bottom plate. So the bottom plate is 95 over 53, right? The width is 12. The thickness is 0.5. Okay, so 95 over 53 times 12 times 0.5 is equal to 570 over 53. Okay, so next we're going to take individual y bar. So I'm going to take datum from the top. Okay, I declare datum from the top. So this is equal to 0.5 divided by 2, 0.25, right? So no doubt I take datum from the top, right? 2 and 3, they also start from the top, right? So this is straightforward. So this is 6 divided by 2, 3. Part 2 and 3 are the same. And the bottom one is 6 minus by 0.5 divided by 2. So this is equal to 0.5 to 6 minus, so it's equal to 5.75. Okay. Then from here, we're going to multiply our n w d y bar. Okay. So 6 times by 25 is equal to 1.5. 3 times by 285 over 53 is equal to 855 over 53. I know this is quite tedious. I understand that, okay, but it's important to find this accurately. So this is equal to, is equal to 5.75 multiplied by 570 over 53 is equal to 6555 over 106. Okay, then you take the summation, right? So 6 plus by 285 over 53 times 2 times by 570 over 53 is equal to 1458 over 53. Okay, and 1.5 plus by 855 over 53 times 2 plus by 6555 over by 106. So this is equal to 5067 over 53. 5067. Right, so we find our centroid. Y bar is equal to 5067 over 53 divided by 1.1458 over 53. Okay, so 5067 over 1458. So this is equal to 3.475 millimeters from the top, or 2.525 from the bottom. Okay, and then from here we are going to find the second moment of area. Okay, so that's why it's important to get this table right. Okay, so IZZ1. So again, no need to look at the dimension anymore. Just look at the table. All right, IZZ1. So width, right, and then you have 0.5 cube divided by 12 plus by the cross-sectional area 6 multiplied by 3.475 minus by 0.25 squared. Okay, so you write this out. So 1 times 12 times 0.5 power 3 divided by 12 is 0.125 plus by 3.475 multiplied minus by 0.25 squared times by 6 is equal to 62.404. So this is equal to 0.125 plus 62.404 is equal to 65.62.529 inches to the power 4. Then you do IZZ2 is equal to IZZ3, right? Because they have the same geometry. So it's 95 over 53. So this is the width 0.5, 6 power cube divided by 12 plus by the cross-sectional area is 285 over 53. Okay, so 3.475 minus by 3 squared, right? So 95 over 53 times 0.5 times 6 power 3 divided by 12. So it's 16.132 plus by 3.475 minus 3 squared times by 285 over 53 is equal to 1.213. So this is 16.132 plus 1.213 is equal to 17.345 inches to the power 4. Now you have to be careful, okay? Later on, you need to times 2 for this because there's the left side and the right side, okay? So IZZ 4, okay? So we just look at 95. During the quiz, I realized some of you did not adopt this technique, okay? You follow the solution manual. My advice is don't, okay? Try to adopt what I teach you because it will be safer, okay? Because you are doing your calculation in steps, in stages, not lump everything into one. Because I do give part mark. You can see my marking scheme, right? I give you part mark for this, part mark for this, okay? If you lump everything together, I don't know where you got it right or where you got it wrong. So this is 0.224 plus by 3.475 minus 5.75 squared times by 5.023 is 55.662. So 0.224 plus 55.662 is equal to 55.886. Okay. So on that, we can calculate our IZZ, right? So IZZ for everything is equal to IZZ1 is 62.529 plus by twice of 17.345 and then plus by 55.886. Okay. So this is equal to 62.529 plus 2 times 17.345 plus 162.529 plus 2 times 17.345 plus 55.886. So it's equal to 153. I get 1 Let me do it. 62.529 plus by 2 times 17.345 plus by 55.886 is equal to 153.105 inches to power of 4. Okay, let me do it again. Okay, so 62.529 plus by 17.345 times 2 plus by 55.886 is 153.105. Okay, so now that's all we have to do. So the question asks us calculate the maximum stresses. Okay, so I'm going to bring the diagram again. So the question asks us to calculate the maximum stress for the aluminum and the maximum stress for the brass. Okay, so we know, right, if we do this from the top, right, I'm drawing the neutral axis now. Okay, so this is our centroid. Okay, and we know that this dimension from there to here is 3.475, and the dimension from here to here is 2.525. So we are aware, right? We are aware that the maximum stress, right? The maximum stress for the aluminum will be at this point. For the Kevlar, okay, it's also going to be the top because the distance is further than the bottom one, than over here, right? So we know the distance is always going to be 3.475. Okay, so let's calculate the maximum, or before we do that, we want to know the moment about Z. So we are given that the moment is equal to what, 900 pound-feet, and you have to do 900 multiplied by 12. So this is equal to 10800 pound-inch. Okay, so we're going to find the maximum stress for aluminum, and we know that this is the moment vector, right? And it's going to be compression. The head of the moment vector is going to be compression, right? So this is equal to minus 10800 multiplied by 3.475, right? Divide by 153.105. I do apologize. The n value is equal to 1 because our reference material is aluminum, right? So this will be equal to 1 times 10800 times 3.475 divided by 153.105. 1 times 10800 by 3.475 divided by 153.105. So this will be 245 negative 245.126 psi. Okay, let me do it again. 10800 245.126. Okay. So we can calculate the maximum stress